So my dear children, within this activity, we are going to identify how does the light rays are going to behave during a reflection. So within this activity, I have used a mirror over here, a plain mirror, and I have fixed it by using a stand, and there is a white paper which is perpendicular to the mirror. As you can see, it is very perpendicular to the mirror surface, right? Even you can measure the perpendicularness by using the set square. So we'll be using this set square in order to draw out the perpendicular to the lines or the light rays which are going to reflect after when I'm going to direct this laser beam to the mirror. Okay, then after that, in order to complete the ray diagram, I'm going to use a ruler, and to measure the angles I have a protractor, right? I have a protractor. Then we have to draw it, so I have a pencil with me and a laser box. So this laser box is going to direct a laser beam towards the mirror. Then we are going to draw the direction which the light ray is going to travel towards the mirror, and after the reflection we are going to mark the reflected ray also. Then after that we are going to draw out a perpendicular. Then from the perpendicular we are measuring the two angles which are at the either sides of the perpendicular. So this is our aim, my dear children, right? So now let's turn on the laser box like this. So as you can see here, it's getting reflected. So now we need to keep it like this in a steady position, right? Then after we have to draw these lines like this. As you can see here, it's very clear to us from here to here. This is the line which is coming towards the mirror, and this is the laser line which is coming after the reflection process. So we have to draw out those two lines, my dear children. Okay, then we have to use the set square and draw out a perpendicular to the point of reflection, right? Then what we have to do, you have to check the angles at the either sides of the two light rays. So this is our activity, my dear children, right? So you know that we have to do it in a somewhat darker kind of area, otherwise you won't be able to observe this thing very clearly, right? So I will low down the light rays, right, which is in the background. Then we'll continue the activity after that. So my dear children, now we have darkened the room, so it's time to conduct our activity then. So this is the light ray which is passing towards the mirror, and this is the light ray, this one is the light ray which is passing away from the mirror after the reflection. So first of all we have to draw the straight line which is coming from the mirror surface. So we'll draw it like this. And the other thing is, when you are placing this thing, the mirror, always check whether it is perpendicular to the paper, right? You can use the set square in order to check the perpendicular, right? Now let's draw the line first. Right, now let's take the smaller ruler. I'll use the set square because it is somewhat difficult to use the longer ruler, but however, my dear children, when you are completing the ray diagram, you have to use the longer one, right? So we'll use the smaller one here just to mark out the line or the light ray which is going to reflect after the process of reflection or after meeting the mirror, right? So my dear children, now it's time to draw out the two lines. So I'll keep the set square like this, and let's mark out the straight line. Right. Now the line after the reflection. Okay, now let's draw the line once more. Okay, so we have marked the two lines, my dear children. Now let's take out the mirror and we'll complete the ray diagram. After that, then let's measure the angle between it after making a perpendicular. So my dear children, we have drawn the two straight lines. This is the straight line which is coming towards the mirror surface, and this is the straight line which is going after the reflection process. So now we'll take it out and we'll complete the ray diagram by using a ruler, and after drawing out a perpendicular, let's see what will happen to the two angles. So I'll turn off this thing. We'll take the paper, and now let's complete the ray diagram like this. So this is the light ray which is coming towards the mirror surface. This is the mirror surface, my dear children. So I'll draw some kind of a darker line in order to show that that's the covered area. This is the reflective area. Now let's keep the set square and we'll draw a perpendicular to this line. So when you are drawing the perpendicular, make sure this is in line with the horizontal axis like this. Okay, now let's draw the perpendicular. Right, now we have two angles, my dear children. Right, so this is the first angle and this is the second angle. Right, so there are two angles. Right, so my dear children, now let's draw out the two lines. So I have the two lines here with me. So let's draw the two lines. So this is the light ray which is coming. So we'll complete that into here. Here we go. In the other line, make sure that you complete it accurately. Right. So now this is the light ray which is coming towards the mirror, and this is the light ray which is going after the reflection. Now let's measure the two angles between the perpendicular, my dear children. So as you can see here, this is the 90-degree angle over here. So this is the other straight line which is coming from here. So from here 90 to 10, 20, exactly there is 30 degree of an angle between the perpendicular and the line which is coming towards the straight or the light ray which is coming towards the mirror. So there is a 1, 2, 30 degree angle. 30 degree angle. So I'll mark 30 degree here. Right? There's a 30 degree angle. Now let's head on to see the other side. As you can see here very clearly, once again from 90 to 1, 2, 3, that means 10, 20, 30. There are 30 units once again from here to here also, from the perpendicular to the light ray which is coming after the reflection. So once again there is 30 degrees over here. Right, so from this activity we can clearly observe that the angle between the perpendicular and the light ray which is coming towards the mirror, and angle between the perpendicular and the light ray which is going after the reflection are equal to each other. Within this activity, it was 30 degrees each. 30 degrees each. So my dear children, the light rays which is coming towards the mirror, this light ray is referred as the incident ray. This is the incident ray. So the light ray which is going after the reflection process, or the bouncing back light ray is referred as light ray which was bounced back after hitting on the mirror surface is referred as the reflected ray. The imaginary line, this is not actually a line. We drew that line. There was no line over there when we are doing the activity. As you can see, it was very clear to us that the laser beam just going to hit the mirror and reflect it after hitting the mirror. However, there was no any perpendicular in it. But I have driven the perpendicular so that to check what will happen to the two angles at the other sides. So this is an imaginary line which we drew in order to check the conditions which is going to happen during a reflection. So this line which we drew to the which is going to be perpendicular to the point of reflection is referred as the normal. So this is called as the normal. The incident ray, light ray which is coming towards the mirror, and this is the reflected ray. So this is the mirror surface, my dear children. So the other condition is that always this normal is perpendicular to the mirror surface. Always remember, it is a perpendicular line to the mirror surface. Right then, so from this activity we can clearly observe that the angle between normal and the incident ray is equal to the angle between normal and the reflected ray. These two angles are specially called as the angle of incident and the angle of reflection, my dear children. So you will be learning about these things quite more. Right then, so this is our activity, my dear children. So we have finalized the activity. From this activity, we can come into a conclusion that the incident angle is equal to the angle of reflection during a plane mirror reflection. Right then, so once again, let's head on to the classroom and we'll write down our observations and conclusions. So my dear children, within this activity, we'll be using several pins, and using these pins, we'll be conducting the same activity like in the previous occasion. We're going to find out the reflected ray and the incident ray. And once again, we are going to draw out a normal and to find out the angle at the either sides of the reflected ray and the incident ray. Okay. So within this activity, we'll be doing the activities in some kind of a different way. We are not going to use a laser beam or any kind of thing like that. However, we'll be using the reflection of the reflections or the images created by one pin, right, in order to get the in order to get the reflected ray and the incident ray. So here we will be using pins. So what you have to do is you have to direct the pin like this in a position like in an angular position. But however, before that, my dear children, you have to draw out the mirror line like this. So this is the mirror line now. Okay, so in this, like in the same activity which we did earlier, right, we have the instruments with me. Instead of the laser box, I have several pins with me right now. So what you have to do, you just point one pin like in an angular position. Don't make it like direct come in contact with, like, you know, like you don't pin this thing directly towards the mirror like this, but make it into an angle like this. Okay, now as there are plenty of light in the environment, we won't be able to observe the image created by the pin or the shadow of the pin. So there are like several shadows over here. So we won't be able to connect the second pin by using the image or the shadow of the first pin which I have pinned over here. So what you have to do is, now what I'm going to do is, I'm going to reduce the light amount or the amount of light in the environment. So by that way, I'm going to take out a shadow of the first pin. Then on the shadow of the first pin, I'm going to keep the second pin, right? So that they would lie on a straight line. Okay. So we'll reduce the light, and on the shadow of the first pin, we'll pin out the second one. Okay. Right. As you can see here, my dear children, this is the first pin. Now we have darkened the room. So upon darkening, you know that we can clearly observe the shadow of the first pin. So what you have to do is, you have to insert another pin, right? You have to insert another pin along the shadow of the first pin. So this is the first pin. Along this shadow, you have to insert another one. So carefully, I'm going to insert another one. Here we go. Right. So, right. Now, as you can see here, now this is the first pin. This is the second one. So this line is a now straight line, right? So my dear children, now you can see from the other side, see from this side, the reflection of the shadow is now coming from the mirror, like this is the one. So along that line, now we have to insert one pin like this, right? Now another one in the same shadow like this. Okay. Now we have to complete out the ray diagram, right? So this is the line which is coming towards the mirror, or this is the incident ray. Now this is the line which is going after the reflection. So that's the reflected ray. So this is the mirror surface, my dear children. Now we'll take this thing out and we'll complete the ray diagram by using these lines. Then after that, we'll draw out a perpendicular and let's observe what's going to happen with the two angles. Right. So my dear children, as you can see here, these are the two pins which I have inserted as the incident ray. So these are the two pins which I have inserted as the reflected ray. Now it's time to draw out our ray diagram related to the reflection. So we'll take this thing out gently and we'll draw out the ray diagram now. So we have marked as you can see here, I have marked out the line of the mirror, plane mirror, right? So now we have to take this thing out very gently and we'll draw out the ray diagram. Remember, when you are taking this thing out, it's very important not to move these pins, otherwise the straight line will not be accurate. Okay, right? So we'll take this thing out and we'll draw out the diagram. So my dear children, now this is our board that has the pins. So what I'm going to do is, I'm going to gently remove these pins. Let's take the white cardboard out, or the A4 sheet here. Keep it in here. So now we have to complete the ray diagram by using these dots joining towards the mirror surface. So this is the mirror surface, my dear children. So I'll dark the area to indicate the darker area of the mirror. So this is the darker area. Over here, this was the reflective area. Now we'll draw out the ray diagram. Light ray which is coming towards the mirror, incident ray. Light ray which is reflected, the reflected ray. Then we'll use the set square to draw the perpendicular line. So I'm going to mark 2 points, then by using the ruler I'm going to complete the perpendicular line, my dear children. Here we go then. So when you are drawing these lines, you have to be very careful to be very accurate. Otherwise your readings will get faulty, right? So this should be done in a very serious and a very patient manner. Okay, now let's measure the two angles. As you can see here, it's very clear to us that this is the 90-degree perpendicular, this is the mirror surface, the 90-degree perpendicular, this is the mirror surface. This angle indicates the angle between the incident ray, and this was called as the normal. I think you could remember the normal. So incident ray, and this is the normal. So angle between the incident ray and normal is here it is 90. So this is 10, 20. That means 20 degrees. Exactly at 70. From 70 to 90 there are 20 degrees. Then here from 90 to 110. Can you see that? From 90 to 110. From 90 to 110. Once again there is 20 degrees. So this is the angle between the normal and the reflected ray. So once again we could get the same observation and the conclusion. It's very clear to us that always in a reflection, my dear children. So this reflection is quite important, because we have reflected the light rays by using a plane mirror. So in a plane mirror reflection, you can clearly observe that the angle between the incident ray and the perpendicular drawn to the surface of the mirror at the point of reflection. So this was named as the normal. So the angle between normal and the incident ray is equal to here the angle between normal and the reflected ray. So it's very simple to us that, or else it's very obvious to us that from this activity, from these two activities actually, we can see that, or we can prove that, we can finally come into a conclusion that always the angle between the incident ray and the normal is getting equal to the angle between the reflected ray and the normal. So once again we'll head on to the classroom, my dear children, and we'll write down our observations and the conclusions. So my dear children, with this activity we'll be observing about how does the reflection is going to happen in a smooth surface and in a rough surface. So I have with me several surfaces. So I have a metallic aluminium surface here right now with me, and this is a aluminium coated one. As you can see here the surface is very rough, and here in this aluminium sheet, within this sheet the surface is somewhat smoother than the previous one. And now I have with me here a plane mirror. As you know that plane mirror has the smoothest surface. Okay, so now let's observe like what kind of a pattern that we can observe after the reflection of light rays in each of these occasions. So in the first occasion or in the first instance, I'll be using a laser box. Here I'll be using several light rays in order to identify the reflection. Okay. Right. So this is the laser box now. As you can see, there are now 1, 2, 3, 4, 5 light rays. So now by placing the plane mirror, we'll observe what will happen. So as you can see here the light rays are traveling parallel to the, parallel to each other. All the light rays are parallel to each other. So I'll use this laser beam so that you can observe it very clearly. See, these light rays, these ones are parallel to each other. Each of the light rays are parallel to each other. Now let's take the second surface and we'll observe what's going to happen over there. And now in the second surface, my dear children, as you can see, the lines are actually not that much parallel. See, within here you can observe, like in here, this area you can see lines are not that much parallel like in the previous case, right? Now let's use the third one. Right. So as you can see here, now the light rays are actually, we won't be able to observe the lines even, right? So here, as you can see here, the lines are getting scattered here and there. These lines are heavily getting scattered here and there, right? Once again, we'll observe, my dear children. See, this is the plane mirror. So it's very clear to us that the plane mirror is reflecting light rays parallel to each other. Then the second one, see, the metal plate, aluminum plate, somewhat parallel. Actually those things are not parallel, but somewhat actually we can see the straight line, like somewhat. Okay. But then the third one, here we won't be able to observe any kind of a straight line because the light rays are scattered here and there, right? Okay, now we'll use the second instrument. I'll keep it over here. Second instrument is a laser light. Okay, so I'll use the laser light first with the mirror. Right. Now the case is that we won't be able to observe the light ray which is coming towards the plane mirror in this case because the area is, or our environment is somewhat lightened. So we'll dark the environment and we'll observe what's going to happen. Right, now the environment has darkened, my dear children. Now let's observe the light ray reflection of the laser beam. Right. So as you can see here, the laser beam also getting reflected on a straight line, a clear straight line, right? Now let's observe by using a metal plate. Right, as you can see here, it's getting reflected, but however, like in the previous case, the reflection is not that much straight, not that much getting in a straight line because here the light rays are getting spreaded somewhat. See, over the point of reflection here you can clearly observe that the light rays are getting spreaded somewhat. Okay, light rays are getting spreaded somewhat. Once again we'll use the mirror, my dear children. See, there's a clear difference between the surfaces. Now let's use the third one, the final one. So as you can see here, the light rays are getting spreaded here and there. Even we won't be able to observe the line which is passing after the reflection, right? Okay, now we'll use a torch, a flashlight. Right. So this is the pattern that we can observe through a flashlight, my dear children. As you can see, the light rays are getting spreaded here and there. It's getting diffused here and there over the surface. Now let's move on with the plane mirror one. So as you can see here, plane mirror one is giving out a parallel light beam. We can clearly observe the parallel light beam, right? As you can see here now, it's very clear to us that the plane mirror is reflecting the light beams parallel to each other, right? It's very parallel, unlike the previous case. Right, we'll use the third one also, the metallic surface. Here you can see it's showing some kind of a straight line thing, but however those things are not parallel, my dear children, right? So these are the surfaces, my dear children. Right, we'll use the laser beam once more. Check the reflection. So light rays are getting scattered by the surface of aluminium sheet, my dear children. Once again, we'll use the plane mirror. Here the light rays are parallel to each other. Light rays are parallel to each other. It's very clear to us that the light rays are parallel. Then we'll use the third one, the final surface. Here the light rays are getting scattered here and there. Right then. So let's see what are our explanations then. Right, my dear children. Now, what is the reason for having a scattered reflection in this one and within here a clear parallel reflection, and in here somewhat, like it's not actually parallel, but however we can observe some kind of a straight line reflection. It's because that the nature of the surface, my dear children. Now here you know that the surface is very rough, so it is showing a scattered reflection. This scattered reflection is referred as the diffuse reflection. Diffuse reflection. If the surface is somewhat smoother, then we can observe a good reflection like in a plane mirror, my dear children. So that reflection is called the regular reflection, right? The regular reflection. Regular reflection and the scattered or else the diffuse reflection. Right then. So these are the two reflection types that we can observe according to the nature of the surface. When the surface is rough, always we can observe a diffuse reflection, and if the surface is smooth, we can observe a regular or else a parallel reflection. Right then. So let's head on to the classroom once more and we'll observe the other contents in the lesson. So my dear children, within this activity, we'll be observing how does the images are getting created by a plane mirror. So to do this activity, I have a cardboard box and a flashlight. So within this cardboard box, there is a small bit of a opening, and this small bit of an opening is right here over there. You can observe it. Here I have inserted a longitudinal area, some kind of a longitudinal part have been removed. So we'll be inserting the torch within the cardboard box. Then we'll be directing a small bit of a light beam towards the mirror by using this longitudinal section. Okay, right. So let's insert the flashlight to the cardboard box. Right, so we have inserted the torch or the flashlight into it now. So I'm going to direct it now towards the mirror. So as you can see here, it's very clear to you. Actually, I won't be able to observe this thing, my dear children. You are the ones who are observing this thing very clearly. Now this is the box, right? The real box. But however, when you are observing the image, actually the image is being observed like as the object. You can observe the image which is over here from the mirror. See? So this is the object. Actually now this object is pointing a flashlight towards you guys. But however, it is not the object, my dear children. That's the image of it. See? Now this is the real object, this is the image, right? But however, you can observe that the object is like that, which is the one which is pointing out a light beam for you guys when you zoom it in like this. See? However, that's not the object, it's the mirror and it's the reflection of the real object, my dear children. Right then. So this is our activity then. So we'll head on to the classroom and we'll identify the other contents in the lesson. So my dear children, within this activity, I have two laser boxes. Now, two laser beams are directed towards the plane mirror over here through this cardboard sheet that has a small bit of a hole, small line of a hole like this. Okay, so through the hole, right, through that hole, two lines of or two laser beams are directed towards the plane mirror which is over here. Now our aim is to observe these laser beams by using the plane mirror. Remember, these laser beams are very dangerous. So if you are at home, right, or if you have any lasers at your home, don't even try to look at these things from your direct naked eye. Okay, so these things are very dangerous. So our aim is to identify and observe these two laser beams from the plane mirror. Okay, so if you can see, right, if you observe it very clearly, you can observe it like this. The plane mirror, within the plane mirror, the image is going to fire up two laser beams towards you guys through this hole which is placed between the cardboard sheet. Okay, so that would be our observation. So let's see whether we can observe this thing. So if you observe this thing very clearly, my dear children, now you can see that if you directly observe through the mirror, you can see that the laser beams are directed towards you guys. But however, you won't be able to observe this cardboard sheet, but you can observe some kind of an image which is created inside the mirror, and that image is the one which is directing two laser beams towards you guys, right? But if you observe it very clearly, that two laser beams are being directed not from here but from here. Okay, so by using these types of two laser beams, we can find out the images created by the plane mirror. Okay, so within next activity, my dear children, now I'm going to show how to find out the position of the image created by these plane mirror images. Okay, usually in a plane mirror image, we can find out the position of the image which is created by using the same phenomena like in here. Now over there we'll be using two different light rays directed like this, and we'll be drawing out a certain ray diagram in order to find out the position of the image. So we'll find out how to draw it in our next activity. So my dear children, I think you can remember in the earlier activity we did an experiment by using two laser beams to show the reflection which is going to happen through a plane mirror. Over there, we observed the image created by the plane mirror. Now, this is same as to that practical or else the activity. However, here within this practical, we'll be drawing the related ray diagram by using our instruments over here. Okay, so we are just drawing out the ray diagram related to the previous activity within this activity, my dear children. So you know that there are two main activities, or there are two main laws related to the plane mirror reflections. So in a plane mirror reflection, you know that always the incident angle is equal to reflected angle. So by using that principle, we'll be drawing the ray diagram related to plane mirror reflections. So I'll use the ruler first. So this is the, in here at the middle, I'll draw the plane mirror. So this is my plane mirror, my dear children. So over here, this is the darker surface. Right? and over here at my side the reflective surface. Now I'll mark a point like in here. So I'll name this point as X. So my dear children, now this is the point X. Now from point X, we'll be drawing two straight lines towards the plane mirror, which is marked over here. So this is the mirror surface. So we'll draw two straight lines towards the plane mirror, and by that way, we'll get the reflections of those two straight lines. Okay, actually straight lines means in here light rays. Okay, so we'll get the two reflections. So when we are taking the reflections, remember the angle between the incident ray and the normal should equal to the angle between normal and the reflected ray. Okay, right. So we'll draw out the two straight lines first. So before drawing, I'm going to use the perpendicular, right? So this is the perpendicular, one perpendicular. So this is the first perpendicular, my dear children, as you can see. See, it's exactly 90 degrees. So now what I'm going to do is I'm going to draw out an angle, right? So let's take around 30-degree angle. From here, let's take a 30-degree angle. So here 10, 20, 30, 30-degree angle. Once again to here also 30-degree angle. Make sure you are marking these angles. It should have to be very accurate, okay? Now let's right, once again let's see how much is the angle now. Yes, it is exactly 30 degrees. So we'll take 30 to here and we'll draw the reflection. Right, so this is the first light ray from point X. Right, now let's head on to get the second light ray. I'll use a pen for it. So the second light ray, like this, then the perpendicular. Now let's measure the angle. Here 10, 20, 30, 40, 45 and 47. So 47. So 47 each. I took 47 degrees each. So here to here 47, then here to here 47. Now let's draw the angle. First of all, the perpendicular, then the reflected ray. Right. So my dear children, now we have drawn two straight lines. This is the first straight line from the pencil, which is coming towards the mirror. So this is the mirror, right? This is the point X, the object. This angle we took as 30 and here also 30. This is the incident angle of the first light ray and this is the reflected angle of the first light ray. So both are equal. So here 47, here also 47. The incident and the reflected angles of second light ray. Now these are the two light rays which are going away from the mirror, or two reflected light rays. Now we'll draw the reflected light rays towards the mirror, then once again to the once again beyond the mirror in order to get the image. Right. Now this should be our image, my dear children. This is the object, right? So now what I'm going to do is I'm going to check how much is the distance between object and the mirror. So I'll use a straight line and I'll check how much is the distance. So let's measure. So as you can see here, it's around 6.7. 6.7. Now let's take the distance between image and the mirror. Once again, I'll use a straight line. Now let's check. When you check it, it's nearly around 6.7. Nearly around 6.7, right? So here also 6.7. So the distance between, now this is the distance between mirror and the image. This is the distance between object and the mirror. As you can see, it's very clear to us that the distance between object and the mirror is getting equal to distance between image and the mirror, right? If you draw it very accurately, then you can get these answers, my dear children. However, there can be like 1 or 2 millimeter difference. It's because that when we are drawing these things, there can be like simple bit of errors, right? But there can't be any errors like few centimeters. I'm just talking about there can be a very slight more difference between the real and the, real means the object and the mirror length, and the mirror and image length. Like there can be a very small tiny bit of errors like 1 or 2 millimeters, right? Not a dramatical one, but however like 1 or 2 millimeter there can be a small bit of a difference, because when we are drawing lines, right, there can be small bit of errors, right? Technical errors, right? Then, so within this activity, it's clear to us that during a plane mirror reflection, the distance between object and the mirror is getting equal to the distance between mirror and the image. It's quite obvious to us. And also, this is the mirror, my dear children, and within the mirror, image is getting created. When you observe images through a plane mirror, you can see that the image is getting created within the mirror. Okay, so this is the activity that we have conducted to draw the ray diagrams related to plane mirror reflections. Now let's head on to the classroom once again and we'll observe the other contents in the lesson. So, my dear children, I have with me several objects. There are different letters written on these sheets. The letter D, simple D, right? Then capital B is there. Capital F is there. And O, right? Then I have another plastic material. So this is also a type of an object. So what I'm going to do is I'm going to place this thing near the mirror and observe what are the features of the image created by this object. So when you place it like this, right, you can see that the image is getting created within the mirror. So this image is very identical to the object, right? And the other thing is that towards the direction, you can see that the point of this object is upward. So in the mirror image also that point is upward. So we can say that the image is upright. Upright means to the same direction as the object, the image is getting created within the mirror, right? So this is an upright or else erect image. Image is erect or else upright. Then the other thing is that, my dear children, we won't be able to take this image to a different screen. As you can see here, it's always created within the mirror, inside the mirror. As these images cannot be taken to a different screen, a separate screen, these types of images created within the mirror are referred as virtual images. Virtual images. There are some kinds of mirrors, right, where the image can be taken into a different screen, right? I think in grade 7 you have heard about the convex mirrors. So convex mirrors has that ability, right? Convex mirrors has that ability. Okay. Concave mirrors also has that ability. Concave mirrors has the ability. Convex mirrors will not be able to provide any kind of a like real images in convex mirrors. But however, in concave mirrors, not in the convex, my dear children, concave mirrors. In concave mirrors, I think in grade 7 you have identified about the concave mirrors. Even we took some images related to the concave mirrors. So in concave mirrors, we can take the image to a different screen. So in concave mirrors, we can create real images in concave mirrors. Okay. So my dear children, there is another special property in the images created by plane mirrors. However, in order to observe this special property, we have to use letters. That's why I have prepared these letters. So first of all, I'll use this letter O, right? And I'm going to direct it towards the mirror. When I'm directed this board towards the mirror, always I'll keep my fingers folded like this in my left hand side. This is my left hand. And in my right hand side, I'll keep the fingers open. Okay, right. So this is my left hand. This is my right hand. So observe the image very clearly. So as you can see, this image, I think, does not show any kind of a difference like to the previous ones, right? So that image, the letter O, is also the same as the previous one. However, let's observe another different board then. So I'll keep this one. I'll use letter B. So this is my left hand side. You can see that the letter B, the shapes of the letter B towards my left hand side. So this is my right hand. Let's see. So as you can see here, now it's very clear to us that there is a change in the left hand and right hand directions. There's a clear change, right? There's a clear change between the left and right directions, my dear children. We'll observe another one. This is simple D, right? So let's observe it. So simple D is now like simple B when you observe him from the mirror. Once again, let's observe another one. This is capital F. Let's observe capital F. Capital F is also the same, my dear children. You can observe laterally inverted F. This thing or this special property is called as the lateral inversion. In the lateral inversion, my dear children, left and right side of the image is switched. This is referred as the lateral inversion. The left and the right sides have been switched within the mirror, within the image created within the mirror. Okay. So, in order to observe this left and right switching thing, I'm going to use this letter O once more, and let me color a one half of the letter O by using this pencil. So this is right. So I'm going to color one half of it. Right, now as you can see here, now one half has been totally, from the letter O, one half has been totally colored by using the pencil. Now I'm going to direct it towards the mirror once more. So here we go then. Observe it very clearly. Or now when I'm observing it, my dear children, I have highlighted the right hand side. See, this is my right hand. this is the colored area. So as you can see here, my dear children, this is the area which I have colored by using the pencil. So in order to get a good view, I'll use a marker pen and I'll color this half so that you can observe it very clearly. Only one half, okay? Right. Now you can see it very clearly. This is my right hand side, my dear children. The right hand side. I told you that when I'm directing it, always I'm keeping my fingers open in my right hand side, and in my left hand side I'm going to fold the fingers like this. Okay. Right now I'm going to direct it. See, this half is at my right hand side. Now let's direct it. Okay. Right. So when you are directing it towards the mirror, you can see it very clearly, my dear children. Right? See, it has been switched to the other side. Okay, it has been switched to the other side. So when I am directing this thing towards the mirror, my dear children, you can clearly observe that the image is getting created within the mirror by switching left and right hand sides. You can clearly observe that the colored area now, it's in my, see, left hand side, not in the right hand side. Okay. However, if I'm going to keep it like this, now we can see that it is at the right hand side. See, this is my right hand side. You can observe it within my right hand side. When I'm directing it towards the mirror, what will happen? It will switch the directions, left and right. So let's see whether the image is getting upside down or not. That means if the image is getting inverted or not. So in order to observe that, once again I'll mark a dot in here at the top of the letter O. Now let's observe. So as you can see here, there is no change in it. On the top you can observe the dot. In here also, when I keep it like this, you can observe at the top there is a dot. So there is no inversion. I mean, like inversion in here. Vertically it's not getting inverted. However, laterally it is getting inverted. Left and right hand sides are getting switched. Upside down thing is not going to happen. Okay. That's why I told you that these images are erect images. Okay. These images are erect images or else upright images. So we have observed several features related to the plane mirror images, my dear children. Now let's head on to the classroom and we'll complete the table. So my dear children, this is the instrument which is called as the kaleidoscope. So you know that kaleidoscope is made by using 3 plane mirrors which is kept in a prismatic shape like this. So in order to hold the 3 plane mirrors, it's been wrapped around a cardboard sheet and been taped very well so that it will not fall. One side of the kaleidoscope is been covered. See, this area has been covered now. What you have to do is, now I have with me several rigiform balls, right, colored rigiform balls. So what I'm going to do is, I'm going to insert a single rigiform ball into this kaleidoscope. Then you have to, now you can see that within here there's an empty space, right? Within here there's an empty space. So what you have to do, you have to keep your eye, one eye, and you have to observe the patterns. So if I'm going to observe it, it's like this. So like this, you have to observe. So you can insert like several 2 or 3 rigiform balls or any other material into this. Then you can observe, my dear children, like this. So when you observe, now I can see a vivid pattern created within the kaleidoscope. So these patterns are used in designing purposes mainly, my dear children, right? For the designing purposes of tiles, ceramics, and even in clothes also these patterns are being used. Okay. So it's very simple. What you have to do, you just take the kaleidoscope and insert some objects and observe, right? Okay then. So once again, let's head out to the classroom and we'll observe the other things contained in the lesson. So my dear children, this is the instrument called the periscope. So periscope is prepared by using a, now here this periscope is prepared by using a cardboard sheet. Now inside the periscope, my dear children, at the bends of these cardboard sheets, there are two plane mirrors, right? So in here also you can observe a plane mirror, right? In here, within this, right? I think you can see the reflection, right? See? And also in here at the other bend, right? So there are two plane mirrors at the two bends. So when a light ray is coming from this end, is going to travel towards the bend and getting reflected like this, and will hit on the second plane mirror and once again travel back to that direction. So by that way, the light ray is traveling to the sign of Z here. Okay? Means that by avoiding a certain obstacle, we can observe the things or the objects which are located at the other side. So what you have to do here is, you just need to take the periscope and you just need to observe it like this, right? So when you observe it like this, you can see what are the things which are located at the other direction. So these periscopes are widely used in submarines, right? And also sometimes in ships also, right? So I'll show you how does the light rays are getting reflected within the periscope by using a demonstration with a laser beam. So I'll take a laser beam and I'll direct this thing from here. Now I'm directing from this end, my dear children. Observe, you can see on the other side very clearly. See? See, I hope that you can observe the light, the red color laser beam, right? It's mainly because the light rays are getting reflected. It's mainly because the light rays are getting reflected from here to here, then to over there. That's why you can observe the light without any trouble, even though I am directing it parallel to the ground, right, at a certain below level. However, it can be turned some kind of a to an upper level by using the periscope through the reflection of light rays. Right then, so this is the instrument called periscope, my dear children. So let's head on to the classroom and we'll observe what are the other contents in the lesson. So my dear children, within this activity, we'll be investigating about the reflection of sound. You know that sound is a type of a wave, my dear children. Sound is created because of vibrations. So vibrations are types of waves which are traveling through a certain medium. So medium means actually it can be a kind of a liquid, solid, or else a gas. Now when I'm speaking, you know that you can hear the sound. So you can hear the sound because these sound waves are transmitted to you guys through the air as waves. So these waves are referred as electromagnetic waves. We'll be studying about those things in our next grades. So up to now we'll be investigating about how does the sound is going to travel through our normal environment atmosphere, right? In our normal environments atmosphere. So you know that our atmosphere is filled up with air particles. So now within this activity we'll be investigating about how does the reflection of sound is going to occur, right? So when doing this activity, I have prepared two setups of stands with a PVC pipe. Okay, so these two are PVC pipes, the two stands, and now here there is a stopwatch, and in order to fix a board, actually I have a board with me right now. So this is the board. Okay, I'll keep it over here. I'll take it when I'm going to need it. So to fix the board, I have two clay drops. Now let's set up the apparatus first, like this. First of all, we'll keep the stopwatch from here. Then you know that when I'm going to turn this thing on, I can hear the sound very clearly, right? Like this. The stopwatch is working, so I can hear the sound very well. Right. Let's turn this into this direction. Now what I'm going to do is, I'm going to place, right, I'll take this one to over here so that I can keep the two PVC pipes like this. Okay. Now my dear children, I'm going to place the stopwatch from here like this. So as you can see here, when I'm turning the stopwatch on, the sound emitted by the stopwatch will come through the PVC pipe and will hit on the glass sheet over here, and it will reflect and come towards this pipe, and from this end we will be able to hear the sound of the stopwatch. However, you know that now when I'm facing the stopwatch, I can hear the sound still, because sound is going to travel through air and it can come to my ear without any trouble. So in that case, I will be using these two blocks of clay to fix a cardboard sheet, right, like this. Right, my dear children, now I can't hear any sound, right? So what I'm going to do is, I'm going to keep my ear from this PVC end, and I'm going to turn this thing here and there and check whether I can hear the sound clearly or not. Okay, right, now I can hear the sound. Right, now I can hear the sound from this end. Okay, now I can hear the sound from this end, because the sound which is coming from over there is going to hit on this particular glass sheet and going to come towards this direction, and that sound can be heard by me clearly, because the sound is getting reflected when hitting on this glass sheet. Now what I'm going to do is, I'm going to remove the glass. Okay, let's remove the glass sheet and let's observe whether we can hear the sound once again or not. Right. Right, once again we won't be able to hear the sound because now we have removed the glass sheet. Once again, if you place it over here like this, now the sound can be clearly heard, my dear children, without any problem. It's because that sound is getting reflected when struck on an object, right? So that's why we can hear the sound without any trouble. So I'll once again remove these things, right? So now you know that by doing this activity, we can finally conclude that the sound is going to reflect when those things are going to hit on a certain object, right? Right. Okay, then let's head on to the classroom, my dear children. We'll write down our observation and conclusion from the activity. Right, my dear children. Now within this activity, we'll be investigating about how does the refraction of light is going to occur. Now within this activity, they have been instructed to use a beaker with some amount of translucent water. Now here, as you see, when I place this thing over here, and when I'm going to direct the laser beam like this, so you won't be able to observe the light rays which are passing through this medium, my dear children, right? However, you know that when I'm going to direct light like this, you can clearly observe the light rays which are passing from the translucent media, right? However, if I'm directed like this, you won't be able to observe the light rays that are passing from the media which is over here. So in that case, my dear children, we'll be using this flat bottom flask so that we can pour water into it, this translucent water, and in order to observe the area quite well, I'm going to make the empty area or the empty part of the flat bottom flask translucent. How we can make it translucent? I can use this incense sticks, and I'm going to use the smoke of it to fill it with the beaker over here, okay, flask over here, right? So let's keep the flat bottom flask over here. Let's pour some water. Right, so now let's insert the smoke of incense stick into this particular container. You know that there is an empty part, so this empty part should be filled with some kind of a translucent material, otherwise you won't be able to observe the light which is coming from that medium, my dear children. Now here you can see that there is nothing, right? So we won't be able to observe it. So that's why I'm filling this thing by smoke, so that you can observe it very clearly. So let's right, my dear children, now as you can see here, I have filled the container with smoke. Now when I'm going to light this thing, now you can observe the light rays passing from the medium. See, now you can observe it. So first of all, I'm going to direct light like this. So you can see the light rays which is passing from the top of the container towards the bottom, and there is no deviation in the light ray. It's very straight. Right now, so in the earlier case, now we have enclosed this thing by using a smaller beaker, no? So you won't be able to observe it over here. So first of all, I'll use the inclined one, right? So like this, and now you can see it very clearly how it's going to refract. Right, so my dear children, now let's direct the laser beam and we'll observe. First of all, we'll observe from an inclined angle, like an angle. I'm going to insert the laser beam towards the container over here. Okay, now let's see when passing through water what will happen. Right. So as you can see, the light rays are directly passing towards the container, and you can clearly observe there is a bend in the light ray. Light rays are going like this and getting bent and traveling. See, there is a clear bend. As you can see here, there is a clear deviation in the light ray, my dear children. So it's getting bent very clearly. So you can clearly observe the bend. See, there is a clear bend. When I'm going to turn, the bend is also turning. So there is a clear bend between the light rays. There is a clear bend between the light rays, my dear children. Right? Okay. Now I'm going to remove this cup and we'll direct it from the top. So we have to insert it from the top like this now. See? Now there is no such deviation with the beam. Observe, there is no such deviation. However, if I am going to direct it like this, then there is a clear deviation. Right then. So this bending of light rays, my dear children, is referred as the refraction of light. You can clearly observe the bending process when I am going to direct the laser beam toward this translucent material, right? Okay then, so let's head on to the classroom once more and we'll observe the other things on the lesson. So my dear children, within this activity, we'll be investigating further things related to the refraction of light. Here we are going to investigate how does the refraction of light is going to occur through this block of glass. So to investigate about the refraction through a block of glass, I have with me a glass block, then an A4 sheet, white color A4 sheet, few pins, and also the laser box. So what I'm going to do here is I'm going to direct a beam of laser like this, and then what I'm going to do is I'm going to draw out the structure of or the position of glass block. Then by using the refracted ray and the incident ray, I'm going to join those two and create how, or to observe how the refraction is going to occur through the glass tube, right, glass block. So first of all, I'll remove this thing. First of all, we have to mark the position of glass block on the A4 sheet like this. Right, now let's direct the laser beam. Right, so here like this you have to adjust the laser box. Right, so this is the light ray which is passing from the laser box, my dear children, and this is the one which is referred as the incident ray, and the light ray which is coming from over here, this is the refracted ray, refracted ray. So what I'm going to do right now is going to use these pens and point like this. I'm going to point 2 pins right, my dear children. Now let's remove these things gently. Now let's draw out the structure by removing the pins very carefully. So I'll place a tape like this so that it would not move. Okay. Right. Okay, now let's draw the line, my dear children. First of all, the line which coming towards the glass block. Then the line which is going away from the glass block after the refraction. Right, my dear children. Now let's join the 2 lines from a straight line like this. So as you can see here, there is a clear deviation in the path of the light ray. See, there is a clear deviation. So this is the glass block. I'll mark this is as AB. So this is AB. AB is the incident ray, which is the light ray coming towards the glass block. Then BC, B to C, that's our refracted ray, my dear children. So here you can clearly observe the light ray is coming like this and going like this, and the light ray is clearly bent when passing through the glass block. The ray which is coming out of the glass block is referred as the ray of emergence or the emergence ray, right? So once again, when it is emerging from the other side, once again you can clearly observe, right? See, there is a clear bend. So this is the light ray which is coming originally. So there is a clear bend here. When I'm going to put the ruler to the original straight line which is through the glass block, you can see there is an angle over here, right? That angle is created because of the refraction of light, and even in here also you can observe there is an angle. So this is the line of the ruler, my dear children, the straight line. So this is the angle which is getting created. So there is a clear bend in the light ray which is passing from the glass block. Right then. So let's head on to the classroom, my dear children, and we'll observe the other contents in the lesson. So my dear children, within this activity, we'll be observing, due to refraction of light, what kind of incidents which we can observe, especially when we are observing certain thing which is located at a bottom of a water container. Okay, so in order to observe that, I have a glass with me. So what I'm going to do is I'm going to pour some water. So it is a glass container now that has water. So now I have a coin. So let's insert the coin like this. And when we are observing from the top, we can see the bottom very carefully without any trouble. However, when you are observing it from an angle like this, you can observe that the coin has raised somewhat, not at the original position. Right, my dear children? Now, when I'm looking like this, when I'm looking like somewhat, like we can't directly see it like this, you go somewhat back and observe the container. So when observing the container like somewhat backward, you can observe there are two different depths. Actually, I can see here very clearly, even for you guys now, even for you guys also, you can see it very clearly from the video. See, there are two different depths. This is the original depth. This depth which is over here is the apparent depth. So as you can see here, my dear children, this is the actual coin, and there is another coin like over here, right? Like in this area, we can observe another coin. So that's the apparent depth of the apparent depth means, my dear children, here that's the one which we can observe. However, the real depth is somewhat way more greater than that. So we'll mark that apparent depth and we'll observe how much height between the real and the apparent depth. Okay. So, right. So this is the point, my dear children. I have marked the point. Right. Now, as you can see here, this is the depth of the coin which I have marked. But however, that depth is not the real depth, my dear children. The real depth is like over here. So this is the real depth of the coin, my dear children, like in this kind of a area. However, this is the apparent depth which I have marked according to my vision. So this change of depth is created because of the refraction of light rays, right? So this level which I have marked over here is referred as the apparent depth of the coin. And over here you can observe the real depth. So there is a clear difference between the apparent depth and the real depth, my dear children, when you are observing a certain thing, right? Actually here, a water container or else a liquid container. In here we used water. So when you are observing a water container, there are two different levels as the apparent depth and the real depth. Why do we need this thing to identify? It's mainly because sometimes when you go in for a swimming in a like in a watery area, you might feel that now this area is not that much deep. But however, the actual depth can be observed when you come and when you go into that particular water, when you go into that particular watery area. So the real depth is way more, as you can see here within this container also, there is a huge difference between the real and the apparent depth. So the real depth is way more greater than the apparent depth, my dear children. So it's when you guys are going to a watery location, like a lake or else a tank or something like that, or else it can be a pool. So when you are going to a place like that, first of all, make sure that it's not that much deep, right? So don't go ahead and jump into those kind of things, those kind of areas, because it will be harmful for you guys, because actually the depth which we can observe is not the real one, that's the apparent depth. Okay, so this phenomena is occurring because of the refraction of light rays, my dear children. Right, now let's head on to the classroom once again and we'll observe what are the other effects of refraction. So my dear children, within this activity I have a pencil with me. This is the water container. What I'm going to do here is I'm going to insert the pencil into this water container and we are going to observe whether there is any deviation between the lines of the pencil and the pencil which has been part of the pencil which has been inserted to the water. Okay, right. So when you insert it like this, my dear children, and when you go and observe it like this, there is a clear deviation with the path, right? Actually, it's been bent right now like this. There's a clear bend. There's a clear bend like this. We can clearly observe that bend. And even you can observe that the pencil has somewhat, like zoomed in because of the refraction of light through the water. So this effect of bending is occurred. Now you can see that the pencil has bent. So this effect of bending is occurring mainly because of the refraction of light rays, which is coming from the pencil, which is at the container, water container. Okay, so when the light rays are coming towards you guys through the container, right, it is getting refracted, so that the refraction is observed as the bending, right? So this is the next step or the next phenomena related to the refraction of light rays, my dear children, right? So let's head on to the classroom once again and we'll observe the other contents in the lesson day. So my dear children, within this activity we'll be investigating about the refraction process. The process of refraction that is going to occur especially through this object. This particular object is referred as the prism, a triangular prism. So this triangular prism has two triangular surfaces at the either sides, and on the three other sides, like these two sides and the below, there are three rectangular surfaces. There are three rectangular surfaces like this, 1, 2 and 3. And at the either sides, there are two triangular surfaces. So this is the one which is referred as the prism. So when you take a prism, my dear children, prism has the ability to refract light rays, right? So as it is made up with glass, when a certain light ray is coming through the prism, it's getting refracted. A special thing here is that when the white sunlight is getting refracted by the prism, it's getting divided into 7 light rays. So it's getting refracted into 7 light rays. Our white light, my dear children, the white light contained within the sunlight is getting created, it's been created with 7 different colors. These are the colors that we refer as the rainbow colors, right? These are the colors that we refer as the rainbow colors. So this white light is getting separated into those 7 different colors when this white light is passing through a prism. So to direct a beam of light towards a prism, we can use this mirror. You know that when I direct this thing to you guys, you can see that it's getting like reflected, right? So this reflected surface can be used to get a bright beam of light towards the prism. So by that way, like this, you can direct this thing towards the prism and you can get a bright beam towards the prism so that it would refract and create those 7 colors. So by using the prism, we can get the 7 colors, my dear children, right? Now let's observe how to get these 7 colors. Right, my dear children, now in here, as you can see, now I have came to the outside because we have to get some bright white light rays or sun rays. So here now I'm using that reflector, which is the plane mirror, right, to get a direct light beam. So as you can see here, now it's somewhat blurred, but I'll try to make it to a right. Now as you can see here, somewhat blurred, but I'll try to make it to a color that we can see the 7 colors. Right, now as you can see here, starting from red, right, yellow, then green we can observe, then blue, like that there are 7 different colors, right? So this white light is coming directly from the sun. So as you can see here, it's very obvious to us that, right, the color is getting divided into 7 different colors. So this is the mirror which I have planted over the near to my prism, my dear children. So it is getting reflected, see. So as you can see here, so this mirror can be used to reflect the light rays towards the prism. Right, my dear children, I think you have observed what has happened over there. So we have used this prism in order to refract the white light, and we divided that white light by using the prism into 7 different colors. So these are the colors that were named as the rainbow colors. Right, my dear children. So once again, we'll head on to the classroom and we'll conduct the other lesson parts related to the refraction lesson. So my dear children, this is the instrument which is called as the Newton disc. So this Newton disc is consisting several colored portions of a circle, as you can see here. It is this kind of a thing, right? So Sir Isaac Newton was the first founder of this thing. He was a great scientist, you know that, right? So he was the first person to introduce that the white light is composed of 7 different colors like this. So these are the colors actually we identify in the rainbow. So now when I'm going to rotate the wheel of the Newton disc, you can observe actually the white color instead of these 7 colors. Now you can clearly observe there are several colors in the disc. Actually there are 7 colors. So however, in still, if it is however, even though it is showing 7 different colors in the still position, and I'm going to rotate it very fast, it will definitely turn into white color. So that's how the normal light rays are getting created. Normal light rays means including the sun light received by the sun. So the sunlight is also composed of these 7 different colors. I think you could remember that we studied those things under the refraction of white light through a prism. Okay, right, now let's rotate this thing and we'll observe whether we can obtain the white color or not. So you have to rotate very fast, my dear children, like this. So now you can see when rotating very fast, right, when rotating very fast, we can observe the white color, my dear children. Observe the white color. Right, I think you can observe the white color very well. When I'm slowing it down, once again you can observe the same disc which is composed of the colors. Now when I'm rotating it once more, right, you can clearly get the white color. See, right then. So my dear children, this is the instrument called as the Newton discs. So let's head on to the classroom once more and we'll observe the other contents in the lesson.